morning. So today I will give you just a little bit about the concept of chemical equilibrium. So first of all, we have to know about the types of the reactions. We have two types. The one is the reaction is complete in one direction. So we call this a reversible reaction. And the other type is called reversible reaction, which the reactants react together and produce the products. At the same time, that products can react together and become a reactants again, like as shown at the slide. For a chemical equilibrium, when a reversible reaction reacts by the time when the reaction goes on, so the concentration of the reactant will decrease. At the same time, the concentration of the products will increase, right? So when the time goes by, you will see that for a reversible reaction, the products and reactants become the concentration is become constant, and at this stage you can see the shape or can also the shape of the reaction that we call this state as equilibrium. And we see as kinematic. All curves show us a concentration of the reactants and the products. At this stage, the concentration of our species is not changed anymore, so we call this state as equilibrium. So by the way, you can define that the chemical equilibrium is achieved by two ways. And the first is when the rate of the forward reaction and the reverse reaction is equal. And the second is when the concentration of the reactants and the products remain at the final state of the reactant. So how to explain the equilibrium? So if you consider this reaction is called a reversible, when reactants can become products, and by the way, at the same time, the products can become reactants. We can explain it by the ratio of the concentration of the reactants and products. So this ratio is constant. So we call this constant value as K, or we call equilibrium constant. And by the way, we can express K by using a principle of kinetics that Dr. Tanissara gave you a lecture before. So from the point of view of the kinetics, you can explain the rate of the reaction by using a rate equal to K and the concentration of the reactant and raised to the power of the stoichiometric ratio of the chemical. So as you know that when it goes to equilibrium, the rate of the forward reaction, the rate of the forward reaction and the rate of the reverse reaction is equal. So when we derive this reaction, it's become the ratio of the rate constant of the forward reaction and rate constant of the reverse reaction. It's become equal to K when we express the equilibrium state of the reaction. So give you some example. For this example, you can express the equilibrium of the reaction by using K, or the other way by using a principle of non-conformity. By we get a same result by So experiment K equal to concentration of the products divided by concentration of the reactants. Thank you.